Properties of logarithms. Just as exponentials had laws, we've got properties or laws of logarithms. So first, the log of a product equals the sum of two logs, or the log base a of xy equals the log base a of x plus the log base a of y. For example, the log base 2 of 21 could equal log base 2 of 3 plus the log base 2 of 7, because 3 times 7 is 21. So in words again, the log of a product is the sum of the logs. Okay, log base a of x divided by y equals the log base a of x minus the log base a of y. For example, the log base 3 of 10. Now, one way of writing 10 is as the quotient of 70 divided by 7. It's just an example. So I could write the log base 3 of 70 minus the log base 3 of 7, because 70 divided by 7 is 10. In words, the log of a quotient is the difference of the logs. And then log base a of x to the n can be rewritten as n times the log base a of x. So for example, the log base 5 of 8, and 8 could be written as 2 cubed. This could equal 3 times the log base 5 of 2. And in words, the log of a power is the product of the exponent and logs. Now, we don't always have to start from the left and go to the right. We could also start from the right and go to the left. So these properties work in both directions. Okay, let's look at an example. Let's express the log base 3 of 7 minus 1/3 log base 3 of 8 plus log base 3 of 2 as one single log. So I only want to see the word log written once in my answer. Okay, this number out front, the coefficient, can become an exponent on that second log, so I'm keeping the first log the same. Log base 3 of 7 minus log base 3 of 8 to the 1/3, so the 1/3 moved up as an exponent, plus log base 3 of 2. Now, 8 to the 1/3 power is 2, so this becomes log base 3 of 7 minus log base 3 of 2 plus log base 3 of 2. Okay, log base 3 of 2's cancel out, and we're left with log base 3 of 7, which is our answer. There's one more formula called the change of base formula, and this says that if I have a log with base a, log of a with base b, that I could calculate it using the quotient of log of a with base c divided by the log of b of base c. So for example, and a common one that we use, because on your calculators you've noticed that we have a button that's just log, which is the common log or base 10. We could say that the log base b of a equals the log of a divided by the log of b. And our base that we're using is 10. So if we wanted to calculate log base 2 of 6 using our calculators, we would hit log 6 divided by log 2, or log of 6 divided by log of 2, and our calculator would tell us 2.585. So try this. Using the properties on the previous screen, write 4 log base 3 of x plus 1/3 log base 3 of y minus 5 log base 3 of z as one single log. Pause while you try this, looking back at your notes, and then see if you confirm your answer here. Okay, so the coefficients out front are all going to become exponents. So we could rewrite this as log base 3 of x to the 4th plus log base 3 of y to the 1/3 minus log base 3 of z to the 5th power. And the sum of the first two can become the product, log base 3 of x to the 4th times y to the 1/3 minus log base 3 of z to the 5th. Now the difference of two logs becomes a quotient, so log base 3 of x to the 4th times y to the 1/3 over z to the 5th. And that was my answer. Okay, expand this log. So now we're going in the other direction. We've got log of u to the 4th power divided by v, and quotient can be expanded into a difference, so log of u to the 4th minus log of v, and then also that exponent on u, so the u to the 4th, that 4 can come out front, 4 log of u minus log of v.